Hey guys, welcome to lesson 91 today. Now please do make sure that either you or your parents check your email. I did send an email out on March, today is the 23rd. I did switch out a couple of my lesson plans for this lesson here. I decided to split this up into 2 different days. I think that will make it easier instead of trying to cram it all into one lesson here. So please make sure that you do get a copy of that. That way you do the correct homework assignment that matches each lesson. What we're talking about here today, dealing with absolute value inequalities. Now we've talked about absolute value a couple different times this year, so let's review what we already know. Well, what is absolute value? Definition of absolute value is the distance of a number away from 0 on your number line. Remember, your symbol for absolute value is going to be your straight bars that are right next to each other. Now, since absolute value is dealing with distance, it's always going to be a positive number. It doesn't matter which direction you go on your number line, absolute value is always a positive value on your question. Now, the kind of questions that we'll be talking about here today with our absolute value inequalities, what does that mean? It's simply an absolute value question that has an absolute value expression. It's going to be like the absolute value of x is less than 6. Well, in our questions before, we had the absolute value of x was equal to 6. We had our equalities with our equal sign, and now today we'll look at our inequalities, whether it be a less than or a greater than symbol. Now, do you remember with our equal to questions, most of the questions had 2 different answers because you can go to the right so many spaces or you can go to the left so many spaces. We'll see in our questions today and also in our lesson tomorrow, there'll be kind of 2 different sections that we're going to give to our final answer in our question. So that solution to our absolute value inequality is going to be written as what was called a compound inequality. We had 2 different situations with compound inequalities. One of them we'll see today in our lesson. Our answer is in between 2 different numbers. And then what we'll see in tomorrow's continuation is one of the or questions. I'm in one section or I'm in the other section on the Cartesian plane. So let's go ahead and take a look at our first idea for today. The absolute value of x is less than 6. Well, what does that mean? By definition, absolute value is distance away from 0. So this question wants me to identify any numbers whose distance is less than 6 spaces away from 0 on the number line. So I drew up my number line. If the question would have said the absolute value of x equals 6. Well, what numbers are exactly 6 spaces away from 0? They are 6 and also negative 6. Well, our question says I have to go less than 6 spaces away. So let's see if I can do this here. I'm going to draw a little person that is starting here at 0 because absolute value is always distance away from 0. So where is my guy at if he's less than 6 spaces away from 0? He can go to the right all the way up to the number 6, but he can't stop at the number 6 in our question. Where can he go if he decided to go to the left? He can go to the left 6 spaces all the way up to the negative 6, but he can't stop at the negative 6 because then he would be exactly 6 spaces away, but he has to go less than 6 spaces away in our question. So let me go ahead and clear that off here. So what our person is allowed to do, they can go anywhere in between the negative 6 and positive 6, and they would remain 6 spaces away, less than 6 spaces away from 0 on our number line. So they have to stay in between 2 numbers in order to meet the qualifications of the absolute value that has been given to us. So our first situation for today, and the only one we'll look at, we'll do the greater than tomorrow, if the absolute value of x is less than some positive number. So on the top there it says a is a positive number in our question. We'll see a situation at the end of our lesson today. What if that's a negative number? How does that affect our final answer? If your absolute value is supposed to be less than a certain distance, the setup of your final answers is always going to look like this. It says negative a is less than x is less than a. It has to stay in between the negative of the number and also the positive of the number to stay fewer than so many spaces away from 0. What you're going to put in the middle of that absolute value inequality, or in the middle of your answer, is what was ever inside of the absolute value symbol. Inside the symbol was just the letter x, so that's what I have on the inside of the question. So it's got to stay in between two numbers if you have a less than symbol in your question. Let's go ahead and try a couple examples together here. So if I say the absolute value of x is less than 2.5. So that question wants me to identify what numbers are smaller or less than 2.5 spaces away from 0. Because I have a less than question, I have to stay in between two numbers. Well, what two numbers do I have to stay in between? The negative 2.5 and also the positive 2.5. What I have in the middle of my final answer was what was in the inside of my absolute value bar, which was just the letter x. The x is all by itself, so I'm done writing the final answer. Notice when you do give these in-between kind of answers, you do always want to use those two less than symbols. We never give an answer that has two greater than symbols in the question. Now, on my slide here, I'm just going to show you what the graph looks like. You do not need to graph them on your homework tonight, and you'll see that on the lesson plan for what you're going to work with for your homework from your textbook. So where am I at? If I'm in between 2.5 spaces, I'm in between the negative 2.5 and the positive 2.5 in our question. Now, one thing we do want to be careful on these questions, and we'll see the same thing tomorrow in our lesson, I always have to make sure the absolute value symbol is isolated first. I don't want anything on the outside of the symbol, but I can have as much stuff on the inside of the symbol that I want to before I go ahead and set up my final answer. So let's go ahead and look at that on this following question. I have the absolute value of x, and then I see minus 2.2 is less than or equal to 7.8. So I can't write the final answer yet until I have the absolute value symbol completely isolated. So what do I need to do to isolate that absolute value? I need to add 2.2 to both sides of our question. Well, 7.8 plus 2.2, it gave me a 10. So now my question says the absolute value of x is less than or equal to 10. I have the absolute value symbol completely isolated, so I can write down our final answer. The question says, what numbers are less than or exactly 10 spaces away from 0? Because we have the less than symbol, I'm in between two numbers, and I'm in between the negative 10 and our positive 10 on our number line. Notice the symbols that I put in my final answer are just less than or equal to, because that was the original symbol that we saw in our question. Again, here's what the graph would just look like. I'm stuck in between the negative 10 and positive 10, but you're not responsible for drawing those graphs off. I just want you to see what they do look like in our lesson here today. Two more questions just to walk you through to make sure that we do correctly understand. Now on this question, the absolute value symbol is completely isolated, but there's some extra stuff on the inside, and that's okay. I do not want to start this question by subtracting the 4. I would only do that if the 4 was on the outside of the absolute value. I do have a less than symbol, so anytime I have a less than symbol, I'm in between two numbers. What two numbers am I in between? Negative 5 and positive 5, and that's how I've set up my question. Notice in the middle of my answer is the x plus 4, because that's what was in the inside of our absolute value bar. That's what I'm describing in the question. Now the final answer always has to have the x by itself. Remember, we looked at these questions. If you're not sure what to do, you ignore the left side of the questions. You can put your hand over the negative 5 less than or equal to. Well, to get the x by itself, I would need to subtract 4. The minus 4 has to happen to every single part of our question. So negative 5 minus 4 gave me negative 9. There's my less than or equal to with the x. The x is all by itself. I drop down my less than or equal to symbol. On the right side, I also need to subtract 4. So 5 minus 4 gave me 1. The x is all by itself, and that's what it means to solve in your inequality, and there's my final answer. So it's perfectly fine that I don't have the same numbers on each side of my inequality as long as the x is completely by itself. Again, there's just what the picture would look like. I'm stuck in between a negative 9 and a positive 1 for our final answer. One last situation I want to mention, and this is for the following question we're going to look at. The absolute value of x plus 3 is less than 3. Now notice here the absolute value symbol is not isolated. There's a plus 3 on the outside, which means I need to subtract 3 as the first step. So I would have the absolute value of x is less than 0. Whoops, sorry, I forgot my absolute value symbol there. So let me go ahead and draw that in for you. So the absolute value of x is less than 0. Well, we know that absolute value is distance, and distance is always positive. Well, what kind of numbers are less than 0? Negative numbers. numbers. So can an absolute value question be a negative number? No. Okay, so this says the absolute value has a distance of a negative. Well, that can't be true. So what do I do for my final answer? There is no solution. Absolute value could never equal a negative number. Absolute value can't be less than a negative number as well. So notice in our lesson today, anytime that we have a less than symbol, you're in between two numbers, the negative and the positive of that number. And just watch out that you can't be less than a 0 because that would lead you into the negatives. So that would be our no solution. Tomorrow we'll look at our greater than situation and we'll see how do we correctly set up those answers.